Hey, hello everyone. Welcome to the next video on analog digital electronics. In this video, I'm going to discuss with you regarding the how to simulate the three-phase rectifier, how to construct the three-phase rectifier, and how to simulate the three-phase rectifier using PSIM software. I have opened this PSIM software. This is a very beauty of this PSIM software. It is just there are the dots, and by joining the dots you can create the diagram. This software is very easy and amazing. So let me start with the preparing of the three-phase rectifier here. So how to prepare the three-phase rectifier? So I will go into the element from the power, from the switches I will take a diode. I am going to make a diode bridge rectifier. So I am taking this diode bridge rectifier. I am placing one diode over here. Okay, so diode. So let the name of this diode is diode D1. I will display this diode and I am keeping this diode at ideal. Okay, this diode is at ideal. So this is the diode D1. I will copy this, Control C, Control V. Okay, so this is a diode D2. Okay, then this is the diode D3 I am placing here. Okay, this is the diode D4 I am placing here. This is the diode D5 I am placing here. And this is the diode D6 I am placing here. Okay, so let this make all diodes align. See that how I named this diode D1, D4, D3, D6, D5, D2. Why this diode names like this? Why not D1, D2, D3, D4, D5, D6? Why not like this? Because this diode will be come into the operation. First diode D1 will be operate, then D2 will be operate, then D3 will be operate, then D4 will be operate. So according to the sequence of diode operation I am giving this name. How to remember this? Okay, how to give this diode name? So it is easy task. The upper leg diode, give the odd name to the upper leg diode. Okay, give the odd name to the upper leg diode. And for lower diode, as this is the three phase, so add 3 into this. So 1 plus 3, 4. Add 3 into this. Okay, 3 plus 3, 6. Add 5 plus 3, 8. But number of diodes are how many? 6. So 8 minus 6, 2. So this is the 2 number diode. Again I am repeating, give the odd numbers in the upper leg. Here you add this is the three-phase circuit, so you add 3 into this, D1 plus 3, D4, D3 plus 3, D6, D5 plus 3, D8, but number of diodes are 6, so 8 minus 6, 2, hence this is diode number D2. So we have constructed the diode. So let me again I will move this downward, which will create a simplicity in drawing. Okay, so this I have created a three-phase diode over here. I have connected a three-phase diode bridge. Now okay, so this is connected three-phase diode bridge. This is extra branch I will delete. Okay, so from here again I will connect this. I will connect the wire and I will connect all the elements together. Now what is the necessary? I have to do the three-phase AC supply. To construct the three-phase AC supply, what is necessary? We require AC source, or from the simulation you can directly take the AC source. Okay, so element power. Okay, element power from I think in sources. In sources, if you go into the voltage source, three-phase sine wave. I am directly taking this three-phase sine wave here, and I will paste this three-phase sine over here. So what are the specification? Line to line RMS voltage. I am going to construct, this is for line to line voltage of the 415 volt and frequency of the 50 hertz. Frequency of the 50 hertz. Okay, so I am keeping this frequency of the 50 hertz. So this is what my three-phase supply. Okay, so I am giving the name three-phase supply. Okay, three-phase supply. So this is my three-phase supply. So I will click this, so it will be displayed. See, three-phase supply. Instead of 50 I will mention here 50 hertz. Here I will keep it as a hold. So this all things will be displayed here. Now see, all things are displayed. This is regarding the voltage of the three-phase supply. Now I have to connected the three-phase supply to the diode bridge. So the first element is connected here, the second source is connected to the second leg, and third source is connected to the third leg. But see here, it creates a three dot, means it is connected to all, means I have done wrong things. Okay, so I will delete this because this must be connected to the third leg only. So dot indicate connected, so I will take like this and I will connect here. Or what I will do, for simplicity, I will move this all diode once again downward side, selecting all, I am moving to downward side. Then I will connect here. Okay, so and I will delete this, and I will connect this to here. See that I have done the three-phase diode bridge rectifier. Now I want to connect the ground, so I have connected the ground terminal. Right click, by the right click you can rotate the element, so ground element is connected here. Okay, so with respect to ground, next I want to measure the line to line voltages. So line to line voltages voltage measurement must be there. So I must require a 3 voltmeter. So to connect the 3 voltmeter, again this space is not sufficient, so I will move this here. Okay, so I will connect the 3, I want to connect the 3 voltmeter, or let me delete all this. So again I'm trying to make as much as simple possible. Okay, see again it is a 3 dot, means it is wrongly connected. I will move this on upward side. Okay, then I will connect this leg here, this is here. Okay, I will move this on downward side. Okay, initially when you are doing, you will require such types of skill, where to place the element, where to add the element, then you will get idea. Initial skills are very much important. So I have connected this, and now I want to connect the voltmeter. So see that I am going to connect one voltmeter here with respect to other phase, and what is the name of this voltmeter? As it is between AB phase, I will give this name as a VAB. Okay, I will take another voltmeter from here, I will connect between these 2 point. What is the name of this voltmeter? I will give this name of this voltmeter as VBC. Okay, I will take another voltmeter from here, I will connect this voltmeter here, and see I want BC, but this dot is connected to A, so it's AC. So I think I have connected it wrong, so I will delete it, because I want what VAC. So I will rotate it. Okay, so then I will connect here. Okay, so this name is what? VAC, just like a VCA, because dot is connected to the C, hence it is a VCA. Okay, so this is just like your regular diagram. Now I want to connect one ammeter also, so I will take a ammeter. In one phase I am going to measure a source current, so I'm measuring in one phase only because it is a balance. So whatever in the one phase, that is applicable for other two phases. So I will say this is the source current IS. Okay, so this is a source current IS I am measuring here. So these are the input side measurement. Now let us come to the output side. I want this is to be connected to the resistive load. I am going to connect one resistive load here. So this is output. I am going to connect a resistive load, but before connecting to output, I need an ammeter. So I am placing one ammeter here. Okay, I am placing one ammeter here, and so this is connected. What is the name of this ammeter? This is the output voltage, so I will give the name as I0 or IO. I can say it is I0 or IO, you can give any name. Okay, so but remember that name. So this is the resistance. I will set this resistance value to the 50 ohm. Okay, resistance value is to be 50 ohm. I will call this as R L resistance, R load resistance. Okay, load resistance. So this is my load resistance. Now I want to measure the output voltage also. So I am connecting the output voltmeter. I am connecting the voltmeter across the load. See, I am connecting this voltmeter. I am connecting with the wire. So this is the voltmeter across the load. And what is the name of this voltmeter is the V0, that is output voltage V0. So see, my circuit is ready now. Now I want a simulation control. So how I can provide the simulation control to this? So go in the simulate, take the simulation control and copy this. Now you set in the simulation control, you set the time stop time to the 0.2 second, means 0.2 second, and time steps to 1 and to erase to 0.4. Okay, this is a small time step we are giving here. Okay, and 0.2 means almost 10 to 20 cycle. It will show to 10 cycles output. It will show the total 10 cycles output, and I will close it. The simulation control is also placed. Now you save this. I will click on the save. Okay, I will save this model in the desktop with the name 3 phase. Okay, so with the 3ph name I have saved this. Now run simulation. Here you will observe this is the green button which is of run simulation. I will click on this run simulation. Okay, so see this here, it will show in the last in the right hand side corner, it is showing the progress. See, it is showing the progress. Running progress will be indicated here. Yeah, it is 100% completed. Now it is showing you all the measurement. First we will see all voltages AB, BC and CA. I will add these three together so I can able to see the applied voltage. Okay, so let me turn off my screen. Okay, so this is my input which is given VAB, VBC and VCA. So let's take RMS measurement of this. I will click on the measure and let's check the RMS value of this. So I will go into the measure. So see, here it is RMS. So you can see here it is showing. Okay, here it is showing RMS value almost 415 volt. Okay, 415 volt for all phases. This is my RMS value, that is the 415 volt. So RMS value is clearly indicated over here. Okay, so again I will how I can do for mark data point analysis. Okay, so it is showing the average value. You can also see from here. Now let us observe the output voltage. Okay, so I will click on the output voltage and let's check the output voltage. Okay, I will add this output voltage to the screen. Add. Okay, so see the output voltage. See, it is switching between 500 to 800. So let me adjust it axis. I will adjust this y axis. Y axis starting from a 0 to 410 volt. So you can observe this is the DC. DC ripple is between 520 to approximately 580. This is the DC ripple. See how is the continuous output DC almost 5. So how we can see this? I will go in the measure. I will check the I will click here and I will check the from the measure. Okay, so from analysis I will check the average. So see, check the DC average. Okay, you can see, check the DC average. DC average is showing is 560 volt. Around the output is equal to 560 volt. Means giving the 415 input, I am getting the DC output voltage is equal to 460 volt. Okay, so this is the output. Now let us observe the current. I will add the screen of the current. Okay, so screen of the current. Okay, so I will add screen of the current. So you can observe this is the my current. Again it is 10.25 to 11.75. I will adjust its axis. Okay, so axis is from 0 to 11 point something. Okay, जो है वो, so that is showing your DC outputs. It is a constant DC. Some fluctuations are there, but it is a constant DC almost. Let us observe the source side current. So I have added the ammeter. You remember I have added the ammeter over here in the A phase. So let's check the source side current, IS. Okay, So if you check the source side current is, see the fluctuation in is. Is is not a pure sine wave. Is is not a pure sine wave. It is somewhat disturbed sine wave. Means obviously it will, this A to D converter is going to make supplies current imbalance, supply current non-sinusoidal, means it contains a harmonic. It is not a pure sine wave, means it contains a harmonics. So how to check its FFT analysis? You click on the FFT. Okay, you click on the FFT, you will observe that, see here, if we again go into the measure, so you can observe at this, you will observe that the 50 Hertz frequency, my current is 121 ampere, 1.21. See here, there is a which harmonics, you will observe that it frequency is 250, means fifth harmonics. So third harmonics, there is 150 Hertz signal is absent because it is a three-phase circuit. Fifth harmonics, then seventh harmonics, then 11th harmonics, then the 13th harmonics. Likewise, you are able to see the harmonics in the, where you will see the, you will observe the harmonics in the source current. Source voltage is not polluted because source voltage is a pure 50 Hertz signal, but the source current is not a pure. Means if you are using the rectifier, it indicates that the source current is get polluted. Source current is get polluted. Okay, so again I will come back to the time domain analysis. Okay, so this is the my three-phase analysis. Suppose you want to see the voltage across any word diode, so you can take a voltmeter. I will take a 1 voltmeter and I will connect across the diode 1. I will connect across the diode 1 and I will again simulate this circuit, and I will add that circuit. I add that okay, so let me name this diode as this as VD, voltage across VD1. So VD1, voltage across diode 1. So voltage across diode 1 I can see here. And I will add this screen VD1. So where is VD1? VD1. Okay, so VD1 is added. So again I have to click this VD1. Okay, so see here, VD1 voltage across diode 1, means diode 1 will observe approximately 600 volt across it. Peak value across it is a 600 volt during off period. It indicates that your diode must be, though your supply voltage is 415 volt, your diode selection must be greater than 600 volt. Then only diode will be sustained. That thumb rule is that whatever the maximum value coming across diode, take the diode rating double of that. Take the diode rating double of that. So keep in mind, again, whatever the source current you are getting here, take the current rating double of that. So your diode will not be diode will not be burned. Okay, so that is failure of the diode will not be observed. Okay, so I think this okay, so I think this is clear to you. Okay, so I think all these are clear to you. So let me again go here in the vertical line. I will say it is a hide now. Okay, so measurement is hided. Okay, so I will again click on the measurement, so you can see that measurement. Okay, so these are related to the output, how we can check the output of the three-phase rectifier. So let's conclude here. The three-phase rectifier will give you the pure DC, but it pollutes the source current. The voltage, the diode across the voltage across the diode is equal to the maximum voltage of the line to line values of the voltages. Okay, so you will observe that, and almost the DC voltage is constant, hence DC voltage and DC current is a pure DC, hence this is a preferred rectifier circuitry in various industry. Okay, so with this let's conclude today's lecture here. Thank you.